Hi team! Today we are working on lesson 4.7, Triangles and Coordinate Proof. So our objective for today is to position and label triangles for use in coordinate proofs. Before we get going, let's review the properties of isosceles and equilateral triangles that we focused on in lesson 4.6. This is definitely going to come in handy. So, an isosceles triangle is a triangle that has at least two equal side lengths. So at least two equal side lengths. What happens if it has three equal side lengths? No problem. We would just also call this triangle equilateral. But again, for now, if it has two equal side lengths at least, it's an isosceles triangle. Thinking about, okay, what are the properties of angles in an isosceles triangle? Well, it has at least two equal base angles. Again, if all three sides are congruent, then all three angles will be congruent. But at the very least, the two angles that are attached to the two congruent sides are going to be congruent. Here we have an isosceles right triangle. So we've got our right angle here, our two congruent sides. Then remembering that a triangle adds to 180 degrees, and this angle is 90 degrees. What is the measure of each base angle here? 45 degrees. So we could figure out what the angle measure is specifically in this case because we know that this triangle has a right angle in it. But in general, if you have an isosceles triangle, you don't know what those two angles are going to measure, but you do know that they will be equal to one another if the two sides are equal to one another, the two side lengths. And for equilateral triangles, have three equal side lengths. I'm going to put my tick marks on this triangle, and three equal angle measures. Again, remember that a triangle's interior angle sum is 180 degrees. So if you have three equal angle measures, your total is 60 degrees for each angle. Okay, so going on from there, we are positioning and labeling. Okay, now that we have reviewed the properties of isosceles triangles and equilateral triangles, let's get to work and position and label right triangle ABC with leg AB that is 4 units long. So I jumped the gun here. We don't need properties of isosceles or equilateral triangles yet, just thinking about properties of right triangles. So we know that right triangles have a right angle, right? A 90-degree angle. So let's start by thinking, okay, I could point A here at the origin, and the origin is 0, 0. Okay, so if I need leg AB to be 4 units long, I'm going to put point B up here. Well, what does this ordered pair have to be then? If leg AB is going to be 4 units long. Oh, well, it has to be at 0, 4. And then since I have no restrictions on point C, I could put it anywhere down here. So I'm going to connect this right here, right here, right here. Ooh, that was quite the triangle. Sorry about that. Let's redraw that. So since C could be at any point, like I don't know anything else about this triangle, I don't know how long line AC has to be. So I'm just going to use a variable to indicate, hey, it could be at whatever point we wanted it to be. So I'm going to write n, comma 0. So n could be 5 if this was at 5, 0. N could be at 3, 0. N could be at a variety of different places, right? So we'll just use that variable to say, hey, it could be anything. All right? Okay, so now what could a triangle look like perhaps if we drew this right triangle differently with AB that's 4 units long? Well, let's put it right over here. We'll let A be at the origin again. 0, 0. Let's put B back here this time. So instead of this being at, up here it was at 0, 4, what is it going to be if we go 4 units backwards on the x-axis? Oh, it's going to be negative 4, 0. And again, our issue with C. C can be wherever we want it to be. So I'm going to let C be 0, and again to indicate that coordinate, that y coordinate of C, could be wherever we want it to be. So again, AB is 4 units long, and B is at -4, 0, and C is up at 0, n. That n could be any number along that y-axis. Okay, and finally, let's get real fancy. We'll put A again at the origin. Now let's put B up here. Well, where does B have to be if it has to be 4 units long? What, comma, what? 0, 4 this time, so that this would be 4 units long. And we can put C over here, right? So how high is C right now? C's up at 4, but we don't know how far out it is. So I'm going to put n, comma, 4. So again, B and C have to be level. We know that we have a right triangle here. So it is important that C is at something, comma, 4, so that B and C are at the same height. But it can be, you know, anywhere along this line, y equals 4. Okie doke. So here are 4 of the possible diagrams that you could draw if you are positioning triangle ABC with leg AB that is 4 units long. That was the key here. 4 units long. Okay, just a couple quick examples for you here. We are going to now name the missing coordinates of the triangle. And now, if you take a look at this diagram, we've got 2 tick marks here. What does this mean? Oh, this means that this triangle is an isosceles triangle. So we know that we have 2 equal side lengths. All right, let's see how this helps us. So we're going to assign the values to the variables here. We're going to let P be equal to 3. If that's the case, 2 times 3 is 6. So B is really at the point 6, comma, 0. As we keep working through these problems, you'll be able to deal, you know, more and more with variables only and not have to assign specific values to the variables. But for us to kind of get started and start to understand this, let P be 3. So B is going to be at 6, comma, 0. Okay, well, we need to know what is this question mark? What is the value of this question mark here? So if ABC is an isosceles triangle, these 2 sides are equal, well, C is going to appear halfway between A and B. A is at 0, 0. B is at 6, 0. So the x-coordinate of C is going to be halfway between 0 and 6. What's halfway? 3. So C is at 3, Q. Now, why don't we have a value for Q? What does that mean? Well, this point could be higher or lower as long as it is as long as it has an x-coordinate of 3. So as long as it's halfway between A and B, as long as the x-coordinate is halfway between A and B, so halfway between 0 and 6, this triangle could be higher or lower, but that x-coordinate has to be at 3, halfway between 0 and 6. Okay, now for this one over here, we said, all right, we're going to let A be 4. So I'm going to come down here and say, okay, 2 times 4 is 8. So point S is at 8, 0. Again, we know that we've got 2 congruent sides here, and we have a right angle, okay? So the length of this leg down here, the length of this leg is 8 units, right? So since this is an isosceles triangle, this leg also has to be 8 units long, right? And so because of that, it has to be out 8 units to line up with the S, and it has to be up 8 units so that RS and ST are the same measure. So this point is going to be 8, 8. Out 8 units to line up with S, and up 8 units so that RS, which is 8 units long, is going to have the same measure as TS, so that TS can be 8 units long as well. So over 8, out 8 is what we want. Alrighty, team. Just 2 more for us, and then you'll be able to finish the rest for some practice. Name the missing coordinates of each isosceles right triangle. So now we've got a right triangle, and we know that it has 2 equal side lengths. So let's do this first one here. I'm going to put my tick mark there and mark the congruent sides. I'm going to put my 90-degree angle here. Well, let's start out with the easy one. A is at 0, 0. A is at the origin, okay? So now we're going to work with variables here. So for example, say I told you that this was, 5 units long, then I would put 5, 0 here. If I told you this was 10 units long, you'd put 10, 0 here. We're just going to use a variable. So I'm just going to write x, comma 0 right here because it can be any number of units long, okay? And then just like we did before, if AC is x units long, BC has to be x units long as well. So it has to be out x units to line up with C, and B has to be up x units to have a leg that's x units long. And again, if this is confusing, think of it like, all right, say C was at 10, 0. Well, then B would be at 10, 10. I'm just using x so we can say, no matter what our number is, we know that these numbers have to all be the same. Okay? All right, let's do one more over here. Again, we've got an isosceles right triangle, so these are the two congruent legs. Here's our right angle up here now, okay? So let's say if this is 0, 0, let's make this x 0 and this negative x 0, okay? Then up here, h is along the y-axis, so that's 0, comma, y. The height here we don't know because this can be up as high or as low as we want it to be because we already know that we have our two congruent side lengths here. Okay, and I lied. One more problem. We are now going to name the coordinates of each isosceles triangle, so it's not isosceles right this time. It's just an isosceles triangle, so just two congruent sides, and that's all we know. Let's just do this middle one here. So these two side lengths are congruent. So right off the bat, we know, oh, D's at the origin, 0, 0. F is down here along the x-axis, n, comma 0. Where do you think E has to fall in comparison to D and F, knowing that this is an isosceles triangle? We have two equal sides. The middle, it has to be in the middle of 0 and M. So for example, if M was 8, this would have to be at an x-coordinate of 4. If M was 10, E would have to be at an x-coordinate of 5. No matter what it is, it's half of what M is. Okay? And then we don't know how high or low this is, and that's no problem at all. I'm just going to put y as my variable there. All right, team, you will practice more of these in class. Have a wonderful day.